So we are starting with the chapter electrostatics. We'll go through the basics first. So electrostatics, as the word says, electric. So we are studying the electric charges at rest. That is known as electrostatics. So basically, it deals with the study of fields, forces, and potentials which are arising out of this static charges. So firstly, the electricity which with you all we are familiar with first is the frictional electricity, which is developed by rubbing or by friction due to friction. So the electricity developed on the objects when they are rubbed with each other, that those are called as the frictional electricity. For example, when clouds are rubbed against each other, they produce lightning. In winter, when the rubber comb is run fast through your dry hands, the comb attracts small pieces of paper. So those electricities are called static currents. Those are called frictional electricity. Okay. Next is the law of conservation of charges. So the charges or the electric current, electric charges, it states that it can neither be created nor be destroyed, but it's transferred from one part of the part to the another part. So basically, the charges or the energy, it can neither be created, we cannot create it, not it can be destroyed, but it can transfer from one form of the system to the another form of the system. So that is what the conservation of charges has to say. So next is the Coulomb's law. So Coulomb stated this law between the two forces are having two charges. Okay, so this is the law of the attraction or repulsion between the two charges which are kept at a certain distance between each other. That distance we can state it as r. So the force which both of them they will apply on each other, whether that can be an attractive force or repulsion force, that is given by 1 upon 4 pi epsilon naught k q1 q2 upon r square, where q1 and q2 will be the magnitudes of these two charges, r square would be the distance square of the distance between them, 1 upon 4 pi epsilon will be the permittivity of the space, and k will be the dielectric constant out here. Okay, as we know, this k has a formula of epsilon upon epsilon naught. It is the ratio of the permittivity of the medium to the ratio of the permittivity of the medium to the permittivity of vacuum, and it is called as the dielectric constant of the medium with respect to the vacuum. So this is the entire formula. If we have any another medium with other than vacuum, then we can have that dielectric constant medium out here. Okay, so F will be equals to 1 upon 4 pi k q1 q2 upon r square. This gives you the Coulomb's law, that is the electrostatic force of attraction or repulsion between any 2 points or 2 point electric charges at rest. It is directly proportional to the product of the magnitude of the two charges and inversely proportional to the square of the distance between them. The forces act along the line joining the electric charges. Okay. Next, we have the superposition principle of forces. When a large number of forces are acting, or charges are acting on the same, or are acting on the same charge, then there is a superposition of all the of all the forces. That is, when a number of charges are interacting, the total forces on a given charge is the vector sum of the individual force exerted on the given charge by all the other charges. So consider a phenomena where you have four charges q1, q2, q3 and q4, and so q2, q3 and q4 all are exerting some force on q1. So the total force experienced by q1 will be given by the sum of the individual charges by each and experienced by q1 on each. So that is force on 1 due to 2, then 3 due to 1, due to force on 1 due to 3, force on 1 due to 4. So all the charges, all the forces you need to calculate, and we'll have to add them. So the total force will be force 1 2 plus force 1 3 plus force 1 4. That will be the addition for n numbers of forces. We can apply this principle of superposition. Okay, next concept we have is the charge density. That is the amount of charge over a material. That is the linear charge density, that is the length charge density, that is given by the lambda, that is the total number amount of charge per unit length. So it is q by l. If this is a surface, if it can be a sphere, then it will be q upon 4 pi r square. Okay, so if it is a circular ring or any kind of thing, then your length will be q upon 2 pi r. Okay, next the surface charge density, that is given by the sigma, which is the total amount of charge per unit area, per unit surface area. So that is the total charge per unit surface area given by q by a. Then is the volume charge density given by rho, which is equals to the total amount of charge per unit volume, that is given by q upon v, that is given by this rho. Okay, the next concept is this electric field intensity due to a point charge. So we have the definition states that the electric field intensity due to a point charge at any point in the electric field is defined as the electrostatic force exerted by it on the unit positive charge placed at that point. So suppose if we have a charge q which is very strong and it is giving out some is electric field, so at every point the electric at any point the electric field intensity will be the experienced by another test charge which we have is q naught. So the field experienced by this charge, any charge q naught at that particular point, will be given by the strength of the electric field will be given by E equals to F upon q naught, where F will be the force experienced by the q naught upon the q naught will be the magnitude of the q naught. So in general we get this equation to be E equals to 1 upon 4 pi epsilon naught q upon r square, where r square will be the distance between both of them and q will be the charge of this of the Q. So next is the electric potential energies. Now the work which will be done to assemble the system of charges by bringing them from infinity to their present location. That is the amount of work which has to be done to bring two charges from their respective locations to it is stored in the form of a potential energy, and that is given by U, which is equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R. Now the next concept is this electric potential due to a point charge. That is the amount of work done to bring a unit positive charge from infinity to that point against the direction of electric intensity. That is the electric potential V will be equals to W upon Q naught. The work which will, here we have a charge Q and a test charge Q naught. The work which will be done to bring this test charge to a particular point at a distance r, and the amount of work which has to be done against the electric intensity will be given by this V equals to W upon Q naught. So here this W will be if we differentiate, if we integrate it with respect to from infinity to r, from the distance infinity to r, we get the value of 1 upon 4 pi epsilon naught Q upon r. So V equals the electric potential equals to 1 upon 4 pi epsilon naught Q upon r. Next is the electric dipole. Dipole is a system having two opposite charges but equal in magnitude and they are separated by a distance of 2L. Such a dipole is kept in an electric field, and we need to find the torque which is acting on this dipole. So the torque which will be acting has a formula, we can get it as the magnitude of the torque will be equals to magnitude of one of the force, any one of the force, multiplied by the perpendicular distance between the two parallel lines. So the perpendicular distance we can have is this BP. So the torque tau, which is equals to magnitude of one of the force, any one of the force will have magnitude of F, which is equals to E into Q. So multiplied by the BP, that has the value of sine theta. If we get a sine theta, find out the sine theta, that will be BP into 2L, that is opposite upon hypotenuse. So BP becomes equals to 2L sine theta. Substitute the value of BP, that is 2L sine theta over here. You get this the moment, the electric dipole moment is equals to Q into 2L. So this is the this electric dipole moment is Q into TL. You have to substitute this P in the above equation, that is Q into 2L. So that gives you becomes P into E sine theta, where theta will be the angle. So the torque will depend on this angle theta. If the theta becomes equals to 90 degree, then the tau as a sine 90 becomes 1. So tau becomes equals to PE. That is the moment of the torque acting at the 90 degree is maximum.